So that's you also imported the server in Libya from here.
Yes.
So you have got physical servers, ready to use servers.
Yes.
Depending upon the end devices, number of end devices.
Yeah. In this case, it was not easy. Basically, we tried to get during the installation phase. We tried to get VPN-based remote connection to the server because it's easier to handle the project during the installation phase if you can direct connection to the server. But in this case, it was quite difficult. So we had to go to Libya for 1 month, and we had to do all the IT-related job on the field because that remote connection was not good enough.
What is the roughly cost of this server?
400 euros.
400,000 euro.
Roughly.
400,000.
400,000, yes.
Fully redundant. Redundant server?
Yes, of course.
Yes. We used different type of redundancy on the background storages and for the main functions. Okay, thank you for your attention, and you can find some other screenshots after that. And any questions?
I think I was just wondering, I mean, so you have different capacities of servers, right? So I mean, just roughly, if I'm talking to a customer, how do I make a parameter? What is the parameter? Like number of end devices, number of data
yes.
which is being transferred?
Yes, of course, and one of the most important issue is the functionality, because in this case we use 3 servers for reading functionality. I mean, reading the data from the meters. We use that 3 servers to process the data, which means calculate the hourly consumption and so on. We use these servers to write the data in the database, and we use different servers to publish the data for the clients. So the and in this case, these servers are designed for 60,000 PODs, endpoints. In this case, 60,000. In this case, we installed at 6,000 as a first step, 6,000 meter reading devices, which is connected roughly 32,000 endpoints. But that flexible system can be extended. If you have not just 20 operators, but 200, we can install additional server for supporting that functionality, that publishing functionality. If you have more meter, we can install additional servers to improve the reading capacity of the system.
How much data was read in this system?
Sorry, how
How
much?
much data? Active energy accumulated, power factor. These are high consumers.
Hány állomás, tehát hány terület volt, hány
Every 15
station?
minutes, was that a lot of addition?
Actually, I don't know the exact size of the database, but we can calculate it because 15 minutes and 30,000 people. And actually, it depends on the configuration because some of the data some of the POD has only consumption data, but the other one has customers fee and other different quality parameters.
And this is remote configurable, how often you want to have data, which data you would want.
Sorry?
Like, if you'd like to investigate in an area, you'd like to have a lot of data for maybe 24 hours. And after that, you just go back to normal operation. And this is configurable down to
yes, we use the special solution because the basic requirement for GECOL was to use transparent modems, which is not good for us because we don't want to deal with the transparent modem. But we had to reduce our prices, and we found an acceptable solution, which means we used two methods. One is the polling mode, which is quite normal but not good for us, and the other one called push mode, which means data from the meter reading device. So I can show you. So in this case, this is the meter reading device. And the meter reading device has an internal memory and the configuration used by the DNS protocol. And the device has a configuration from the server. This meter has this ID, and this obis codes need to collect. And that device, I would say periodically, every 15 minutes, reads the data from the meters and then send it to the central. So we can, the communication can be optimized between the center and the meter reading devices because the meter reading device does the half part of the work.
How do you handle alarms, events, temporalized in this system?
Just reading the meters in every 15 minutes, nothing more. And if they have alarm, we can send it to the center. But this is not for operation. It is for registration, monitoring, supervising. So that 15 minutes for an alarm, it's more than enough. We don't need to use milliseconds. Okay. Then I would like to continue. And to introduce another system which is connected to Christian and Adi because they participated in this project. AMI system for EON Romania. So if you have questions, please find them directly. The content is the same. Project client history, project introduction, and some next steps. The customer is Energy Romania, which is responsible for the northern part of Romania, with 2.8 million customers. Some history, because we did a lot of gas distribution related application for EON in Hungary. You can see gas management system, information technology project, gas network monitoring system, forecast management system. In addition, fleet and workforce management system for EON. So we have several projects in Hungary for EON, and we had projects in Romania, but in this case, the project connected to the south part of Romania for Gaz de France, District Sud. So Suez, yeah, the new name, GDF Suez Energy. So it was a necessary step to have projects for beyond Romania, but I think it was not as easy. Some general requirements. The maximum number of PODs is 5,000. I think the final decision is 5,500. Some OPC interface, custom reports, and some general requirements. This is I would say, the top level targets of the project. Decisions based on correct information. They want to improve the efficiency of gas trade and distribution. They want to provide high quality service, high level network operation, and in addition to reduce the network operation costs. You can find some details after the presentation. I don't want to show all of them. The preparation phase, the factory acceptance test, installation procedure, and the application itself. The preparation phase was quite interesting for us. Some pictures in a hotel when we have 1 day for the preparation and only 4 hours for doing all the tests. The test was full AMR test for 9 flow computers. You can see one of our colleagues to install the test devices in a hotel, 2 chairs. You can see Ferenc is satisfied. I hope. And you can see the installed test devices with turbines, flow meters, and or field controllers. Probably you participated in this test. In addition, we had to prove the communication ability of our field controller, and that first step was about 9 flow computers, and we only had 8 because the 9th one was not accessible, and during the test phase Adi finalized the test software, and we can so we were successful in the test. Complete list of the correctors. It's 15 different types. Installation workflow. I don't want to give details, but you can see that points, which is a kind of interactive part of the installation. Please call the coordinator, check the results, and don't go anywhere without successful installation. By this way, the required time and resources of the installation can be reduced. Actually, these steps require some additional time, but later the whole cost can be reduced and can be kept into an acceptable level. Some picture of installation. The first step, configuring the SIM cards. The second one is waiting in front of the location. And then the installation connecting to the flow computers and installing the golden lamp.
The flow meters are also KSM, right?
No.
No.
So these are different types, and yes, in Europe there are a lot of, I would say, common type, which can be used in Hungary and in Romania, or even in Poland, but most of the countries are specialized for local manufacturers or favorite types. So actually, now we don't have that flow computer. We use the existing ones. What? Yes,
Yes,
this is
yes.
electors.
There's
Anyway, in Iran, Astra types and well-known types are installed. This is the application structure with normal AMR features and some advanced features connected to gas management system or kind of reports and document system. And of course, that application has a really detailed management interface and management part. Some screenshot. This is a login screen. You can see some different access levels, which is a basic requirement for the customer. Required reports, just the basic ones. Event report availability of the devices. And this is a really important and interesting diagram. Ferenc presented some details, but in this case, it's really interesting because this is a general diagram of a gas distribution company, where different departments and different sections, just like network operation department, sales department, gas purchasing department, and again, general management. Or traditional way, this is the DIWICON system, which has 3 layers, and the traditional way for us to use SCADA system and provide the solution for the dispatchers and for the metrology department. This is the traditional way, but it's not a good way, because even if you have the world best system and that system is only used by some dispatchers, the general management know nothing about your selling solution. In this case, we have several levels, and that levels creates reports. And that reports can be sent directly to the different part of the companies, just like billing report, report for the sales department, report for the purchasing department, and report for the general management. In this case, the general manager will not use our system, and they don't need to use the operation interface of the SCADA application, but they have prepared and useful reports. This is the base reporting activity. This is the second important data from the gas management system, and this is the most important data for the management and for the sales leaders. Some screenshot that innovative tools, the pivot selector, you can select the PODs, you can see the type of the flow computer, you can select by different types, areas, zones, codes, and everything. We can create groups, just like PODs using codes for computer and different other types. You can see all the installation points and PODs in a process display on a map. And now you can zoom in and you can see the station, the required and selected station with all the necessary details. You can see some device status and very detailed trend diagrams. Now we have some additional workflow, just like for creating balance between groups. I copied some other screenshot after the presentation, but the main point for us, we created a really good AMR system for industrial consumers, and that AMR system is cloud compliant and ready for operating in the cloud as a service. Thank you. Any question?